Now you know it's on because it does that bar. Tell me if it ever goes off because one time it messed up, remember? All right, density curves and normal curves. In these two pictures, it's very related. These are density curves because they have area. Area makes density. And if you were to read this whole description on density curves, it might put you to sleep, but let's walk down to the definition. A density curve is all the data is above the above the x-axis. So that's why if I was to graph it like I was trying, notice I'm starting at the x-axis here, and then I'm going up I'm trying to make a smooth curve and get down. All the area that we plotted on our histograms are above the x-axis. Well, that's almost everything you've done so far. Almost everything you've done has been a density curve, except for one small problem. But it's not a big problem because you can make this for anything. We have to assume that the area underneath it is 1. The area is 1, which means 1 equals 100%. So we're talking about all possible samples in that distribution that could be is under that curve, and it makes a distribution. So when we look at a normal curve, we have a small sample, we'll still, it may not even look normal. But if it's close enough to normal, we say, well, it's approximately normal. And all we ever are considering is that it's symmetrical or almost symmetrical. But the truth of the matter is, we are assuming that underneath that curve, it's all the area that could possibly happen, 100%. So we say the area is 1. And so by doing that, if you were to look at this density curve that you could draw in your calculator, you'll notice that it shaded a region. And if you look at it close, he's actually telling you exactly what the area that was shaded. And you should notice that it's a portion of 1. Because last I checked, 0.3109 is less than 1. So in order to have an area of 1, it would have to be all the area. So no matter where you are measuring left and right pieces, it's always going to be a decimal that's greater than 0 and less than 1. Unless you shade in the whole thing, and then it'll be 1. Or if you shade in nothing, the area is going to be 0. Now, this doesn't say much to you because you don't know. Well, you have heard about degrees of freedom, right? It just so happened this degrees of freedom, whatever it was 3. So that's from standard deviation. We talked about degrees of freedom, but this is not about standard deviation at all. This has to do it's probably some sort of, you're going to learn that there are T curves and Z curves. This is probably a T curve. When we do a Z curve, that's more normal. This is not normal. This curve is what? What shape? What's the other shapes? Is it uniform? Skewed to the right, yeah. So the T distribution, you'll hear later on, much later, is skewed. The normal curve, we like to think it's a pretty symmetrical curve, okay? With that being said, maybe now that I've talked about this is basically saying the same thing. He's telling you he went from 2 to 4 right here. See that? 2 to 4. And he's telling you right here, low, 2. So that value was a 2. 4. That value was a 4. So I suspect there's a 1 in there somewhere. 2, 3, 4, 5, 6, 7, 8, 9, and even a 10. So this particular skewed curve was marked 10 equal places, and he went from 2 to 4. And most people would think, well, 2 to 4, that's 2 out of 10. Why is the area not 20%? Why is it 31%, not 20%? Look, if it was a normal curve from 2 to 4, could you see how that could be smaller area than this one? And if so, why would this shape be more than this shape? It's not even. Yeah, you see how the top is being pushed to the left? It gave more area to this 2 to 4 than down here. 2 to 4 doesn't have the privilege of, if this was a pile of mud, and you got and started pushing this mud this way, wouldn't it give you more mud over here? That's what happened. Okay, so it's a little harder to work with a skewed curve. Yep, he did mention it was skewed right. He did mention it went from 0 to 10. He mentioned that the shaded area under this density curve was between 2 and 4, and it was 0.311 or 3109. That meant 31.09% of the data lies between 2 and 4. Okay, so that makes sense. The median of a density curve. Well, if I go back up to the top, I'm going to look at this one here. I'm going to say that I think the mean is here, roughly, and the median is here, roughly. Because why? We've had this talk before. Why? Even distribution, symmetrical. Is that the same case in our beautiful picture here? No. What would you expect? Where would you suspect the median to be now? I'm going to try to erase all my work here so you can get an idea. If I tell you that the median is here, if I tell you the median was there between 2 and 4, if I told you that, where would you suspect the mean be? Give me a direction. On top of this or left or right? Got one person brave enough to say left. Anybody else? You're agreeing with left? Anybody disagreeing? Any rebels? Okay, what did I say about the mean and the tail? Have we been in the same class together? The mean is pulled by what? If the mean is pulled by the tail, where's the tail? To the right. So I hear somebody under their breath saying, yeah. You did, but you didn't say it loud enough to let us all know that you believe that. Were you afraid to be a rebel? Yeah. You don't look like you'd be afraid of anybody or anything. You've got to speak up, because I didn't jump on it right away because I would love someone to challenge it and say, no, didn't you tell us that the mean is always affected by the skewness? Yeah, the mean is always affected by the skewness. So there I'm going to put X bar. You had it reversed in your head? Yeah. Okay, that's fine. As long as you don't mess it up later when it's a quiz or a test or a warm-up. So that's his demonstration here. He basically tells you that the mean is the balancing point. That's why he put this little triangle here. See that triangle? It's a balancing point. So it's not unusual to think that the mean is here. But as soon as there's skewness, if you start pulling on this object and stretching it out, and you are holding it by your finger, balancing it, something has to move to keep it balanced. Because if you keep pulling it out like this side is, it's no longer going to be balancing here because you've just pulled so much distance this way. Kind of like, think of a yardstick. Anybody who's played with the yardstick, you've balanced them before, haven't you? But what would happen if somebody pulled on the yardstick and pulled it farther out? Would it still be balancing there? What would your finger have to do to keep it balanced? Follow the pull, right? Would have to still move, your finger would have to move to where it was being pulled in order to keep it balanced. It's the same thing here. The finger, sounds kind of bad, but the finger, which finger, moves to keep it balanced. Because somebody pulled this tail out. So you have to get that down, that the mean is affected by an outlier, by skewness. The mean is affected. What are you balancing? You got a good balancing point? Yeah. Now shift it over 1 inch and keep your finger there. Well, have someone just slide it over. And don't move your finger. There you go. Oh, what happened? You didn't move the mean to keep it balanced. You didn't move the mean. Well, in that case, you couldn't have. You'd have to move your finger. Right? That was the only way you would combat it. Is you would have to slide your finger over as she's pushing it that way. Yeah, pushing it. I want to say pulling it or pushing it, so I put it together, pushing it. That's what you do when you want to say two things at once. You just merge them together. It's called a word mash. A word mash. Yeah. You guys do it all the time with songs. Yeah. All right, questions on that? All right, we're going to start doing some problems with density curves. Well, this is not the paper that you picked up. You have a paper you picked up which has some problems very similar. So I'm going to help you with these. We're going to do a couple together. Maybe you'll do a couple on your own. But he's saying these are all density curves. It says right here in example 1, to the right is a density curve, which means what? Two things. The area is what? 1. And all the area is where? Above the x-axis. So in this case, he says this curve starts at 0, ends at 1. Remember, the other curve started at 0 and ended at 10. So if I was just playing around with my mathematical skills, I know the bottom of this rectangle. I'll call it a rectangle. I'm not sure if it's a square. I will call it 1. Then what would the other side of the rectangle have to be? Tell me why. Somebody tell me why. The area is 1. So area would have to equal to 1 times 1, which is 1. So I know how high everything goes. So I know if I was to label where this height is on the x-axis, it would be at a 1. Easy enough? Well, I should probably move the axis to be... I should probably move the axis where? Right there. Then you have this one. And that's a 1, and that's a 0, and that's a 1, because you went 1 over. So, no, I just drew the line farther down. There's no area there. The area is in this, I can call it a square now. I remember my geometry that if you have a rectangle and all 4 sides were congruent and all 4 angles were congruent, then it's a square. And I think these are all 4 angles, right angles, right? No, I was just drawing the axes, the y-axis and the x-axis. I just drew them to show you that you could put that on. No, this is y equals to 1. This is the, I'm sorry, this is the x-axis. This was y equals to 1. Sorry. I wrote 1 here. I'll write 0 here. How's that? Does that help now? All right. My bad if I lost you. What percentage of the data lies above 0.7? So what you're supposed to do, now this is the easiest problem. You're supposed to find where 0.7 probably is at. And I don't think you have to be a genius to realize that if this is, the middle's 0.5, isn't it? That would be 0.5, roughly. A little more. Might that be 0.7? Okay. Get the glass. I don't want you getting in trouble. As much, yes, get it all done before I see you tomorrow. Not do tomorrow. I'll let him do it though. That's what he gets. So I want all this area. So you guys who came from strong pre-calculus and strong calculus and strong algebra 2, what's the area of the black rectangle now? Because he is asking me, let me ask for it right, what is the percentage of the data? That's area. So I can do my math. Area would be, help me out, 0.7 times 1, which is 0.7. So there's your first answer. So I'll write it there somewhere, 0.7. Hope they're all that easy. What percent of the data lies below 0.4? Well, I have to find 0.4. 0.4 has to be less than 0.7, less than this 0.5, so it has to be somewhere in there. So I want the area of the yellow square rectangle. It's a rectangle. So we know we went all the way to 0.4, and we know the height is still 1, isn't it? So what's that area? 0.4. 0.4 times 1. So that answer is 0.4. All right, now it says, let me get rid of this, it's in my way. What's the area that lies between 0.3 and 0.9? All right, now I've already written a lot on top of this, so I think I'm forced to have to clean it up a bit and do my area between 0.3, I'll call that right here, 0.3, and 0.9 is almost all the way over here, isn't it? 0.9. So good luck. What's the area of that rectangle in between here? Oh, I think I heard the answer, but they're not loud. They don't want nobody to hear. How'd you get that? Oh, okay, 0.9 minus 0.3, that gave me this distance here was 0.6, and 0.6 times 1 is still 0.6. I agree. Now, I'm going to show you another way to do it because it may not seem important right now. So, but it might be important later on. So let me get rid of my work again.
Mr. Cartwright?
Yes.
For A, it says above 0.7. So
Oh my goodness. How'd you catch that now?
I was thinking about it.
Oh, the whole time? You poor kid. That means you didn't even catch the rest of the problems. Did you catch the mistake she caught?
No.
It sure would help to read the information. It says above 0.7.
Sir, can you start from the very beginning?
No. Well, we almost did right now. And not the lecture part about the definition of a density curve. You'll have to read that page. But we want, let me do it right this time because she caught us. She caught us red-handed. We are here. I want this rectangle, which is interesting. She brings out a very good point. If the area up to that point was 0.7, there's another statistics word called complement. Complement means take one and subtract the answer, and that gives you the other side. So we said this area was 0.7. If the whole area is 1, then 1 minus 0.7 gives us the other side, which is still 0.3. So I want you to keep that word because you're going to hear it again, complement. Yeah, the A was not 0.7. A is 0.3. All right. Let's see. Oh, this is a good one. I don't think anybody's going to figure this one out. Exactly 0.8. Exactly 0.8. So that's about here. So there's my wall. Exactly 0.8.
Would it be 0.1?
Tell me why.
Because you're not doing anything below it or above it. It's just that one.
So
point.
are you saying the thickness of that line is 0.1?
Just guessing, yeah.
Okay, in geometry, what was the width of a line? There is no width. Remember, a line is made up of points, and a point has no dimensions. Therefore, the line that it makes, you still can't see it. It's a construct that we think about. A line is a set of points. Points have no measurement, so their line has no measurement. So if it doesn't have any measurement, what's the area there? 0.
Should it be 0?
It's 0.
Because it's a line.
Because it's a line. But think about it. Why it can't be 0.1. What's the area to the left?
Point.
Say it again.
0.8.
What's the area to the right?
0.2.
What do they add up to?
10.
1. Not 10.
Well, yeah.
1.0. So if the line had dimensions of 0.1, like you thought, then 0.8 plus 0.1 plus 0.2 would be what? Well, 1.1.
1.1.
It can't be 1.1 because the definition of a density curve says it can't be more than 1. So it can't be 1.1.
It has to be 0.
Has to be 0 using our definition. Does that make sense?
Yeah.
Yeah, I wish it was all that easy, but it's not. What is the median of the data? Tell me why it's 0.5.
Yeah.
I agree, 0.5. Why is that the median? It cuts it in what? Well, that's not a good picture. It cuts it. Oh, that's not going to help. Neither is that. I have to be very careful and cut it in half, where this is 50% and this is 50%. So the median has to be that X value, 0.5. What's the mean of the data? Okay, now if you were listening at the beginning of my lesson, what's the mean? Where would you put X bar? I feel like playing the Jeopardy song. Say it again.
0.5 is not skewed to.
Nice. Very good. It's not skewed. So the mean and the median are equal. It's not skewed. It's symmetrical. Matter of fact, it's perfectly symmetrical. Yes, it's uniform. Uniform means looks like a rectangle. That data does look like a rectangle. All rectangles are squares. Not all squares are rectangles, remember? So the mean and the median are the same. So nice job. I'm going to lay 0.5. Extra credit. If I was to get an extra credit, she should, because she caught that mistake, 20 minutes later, but that's faster than I caught it. I would have loved it if she'd have threw something at me before, but you know what? That goes to show it's never too late to correct the teacher.
And not get extra credit.
Oh, I'll probably remember her on something she needs.
And me? I face you?
Well, in our discussion, we're all cooperating, right?
Oh.
Yeah, so. I know. Hey, I no offense. I love what you do. But to catch a blunder like I just did, to catch that when nobody else caught it, even I didn't read the word above, I think that's wonderful. And when I grow up, I want to be just like her. All right? A new density curve. Look at that thing. Look at that. He says it's the density curve. It says right there. To the right is a density curve for the distribution of values between 0 and 2. All right, so I'm looking at it. There's my density curve between 0 and 2. I'm going to use my freedom to say, well, that must mean this stops at 2. And I went straight up, so that's a right angle. I'm allowed to say that the area is how much?
1.
Area is 1. And do I know the base of this triangle?
It's a 1.
How long is it?
2.
My question is, and how high is it? Why? Got to give me a reason. Area equals base times height divided by 2. We know the area has to be 1. Plug in what I know. 2 times the height divided by 2 has to be 1. The 2's canceled, and Mallory has it. The height has to be 1. She's got it. I don't think she guessed, because I asked her why, and she started talking about the formula of base times height divided by 2. So it's not always going to be 1 height. It might be for you right now because they try keeping the problems easy.
What happens if it's more than 1?
Well, it can't be more than 1. I mean, the height?
Yeah.
Well, what if I didn't go out to 2? What if it was a triangle that only went out to 1? Then the height would have to be 2.
Oh, okay.
Yeah, exactly. See how quick she was? That's how I know she didn't guess. She knows the mathematics. I wonder who her geometry teacher was. Oh, I was. She learned. But she was smart before she had me, so it doesn't matter. I guess I didn't hurt her a lot. I mean, she's still smart. So, thank God. That's all a teacher really can hope for. Worst case scenario. Maybe they didn't learn anything, but maybe I didn't hurt them. You know, maybe they're at least as smart as they were when they came to my class. You know, I hate it when sometimes it seems that some students get dumber as they leave a class. And it happens, though. It happens, and sometimes it's the teacher's fault, right?
You remember Evian?
Yeah,
Yeah?
Is it? Yeah, he's still here, isn't he?
Yeah.
Yeah. But he walks around like a cool cucumber now. He doesn't say, walks like, yeah, he doesn't really. He used to be talk.
He has a girlfriend.
Oh, that does it. She said, you straighten up and quit acting childish. All right. We need to use this triangle here. Where is what percentage of the data lies above 1?
Above.
Above 1. And a lot of people who yell out the answer without thinking, they get it wrong. 1 is here. About here. What percentage lies here? Dun, dun, dun. What happened? I'll let you think for a minute.
I love you. Oh my God.
Where did it go? Oh, there it is. There it is. I'm still thinking, so let me copy it. That wasn't right. The original page, and I got to get rid of these extra pictures. Well, I'm going to save this. I think I'm going to save this picture. Save this picture because I might use it again, and I'll get rid of this one here. Okay, so put the answer. Where'd my answer going to go? Oh, you're here. What was the answer? 0.75. Now we want to know what is the percent of the data that's below 0.5. So that, unfortunately, if this is a 2 and this is a 1, I'm basically cutting this in half now, and I'm over here at 1/2. And I want below this. I'm going to not mess up again because she'll yell at me. Below this, I want this little blue triangle. So let me go back to my other page and put that answer down as how much was it? Oh, 1/16. The next one. What percentage of the data lies between 0.2 and 0.8? Oh, 0.6. Is that what it says? Oh, I just can't see it. So I need to clean it up a bit because I can't see anymore. 0.2 and 0.6. Well, 0.2 is kind of small. 0.6 is bigger than 0.5, so it's not even to the 1, so it's kind of small. So it's this thing here. Oh. I'm sort of stuck using the equation for a what? No, it's not a triangle anymore. It's a trapezoid. It's a trapezoid. Well, while I'm here, can somebody tell me what each height's going to be? Remember what our equation was? Y equals to 1/2 x. All I have to do is 1/2 times 1/2. How high does this go? I'm sorry, it wasn't 1/2. It was 0.2. So it's 0.2 times 1/2, or 2/10, which is 1/5. I can do 1/2 times 1/5, can't you? What is that? 1/10. Oh, that's just a 0.1. Now let me find with the 6. 6/10 reduces to 3/5. What's 1/2 times 3/5? 3/10. That's just a 0.3. Okay, now we're cooking with gas. So let's go. Manager's gone for the day. You're stuck with me. What was that answer? How much? 0.08. Which, by the way, has a fraction if you cared about doing 8/100 and make that into 4/50, make that 2/25. I think, if I did it right. No, 2/25? Okay, I'll take your word for it. Yeah, I think so. What is the median of this data? Oh, no. Median? How am I going to do median out of this? Where is that going to be at? Well, is it in the middle? That's the question. Let me get rid of all my scratch work here. Is the median definitely the value that cuts this triangle in half? How do you know that may not be the median? It's skewed. Oh my gosh. See, guys, people do learn. See, it's skewed. So the area to the left does not necessarily add up to the same as the area to the right. I need to force this line to give me a 0.5 and a 0.5 area. So, somebody, please, problem solving. How could I come up with where that x value has to be to guarantee an area 0.5? Somebody. What could I do mathematically? Pretend this is like the problem of all ages. The winner gets this trip to Hawaii. And it's a math contest. And the time is like 3 minutes. You have 3 minutes to come up with a procedure that will give me the x value. I don't know. Somebody knows. Until somebody comes up with it. Well, you're not confused. You're just saying, I don't know how to get those numbers. Which part? Well, simply, I just want to know where to draw that line that would.
Is this the, remember like when you on this one? Okay, so it's basically asking like what lies below 0.5, so they cut that one in half.
That was easy though, right? Yeah.
And then now that's what we're trying to figure out, but I don't know how to figure it out.
Yeah. Well, apparently everybody's staring at each other. And I don't want to keep giving you ideas. I want someone to come to me because if I do the whole thing, what's going to happen is if I put this on a quiz in 2 weeks, you're all gonna yeah, because you're not gonna know it. You're gonna do this. You're gonna say, oh, I remember when he did it. Hey, how'd you do that again? That's what's gonna happen. So I know that's not gonna help you though.
Being exposed.
If I go fishing for you and catch the fish, and then next week you have to go catch your own fish, you're gonna go. You're gonna what? Well, no, you learn by doing. You guys watch all the time. You guys watch all the time. Watching isn't going to necessarily cut it. I'll let you stew on that one.
Can you do that one and then I'll try to do another one? Ooh, how about fun.
I'm going to let you stew on that one. Stew means to think about it. Well, maybe we go to something easier than your brain. What happens when we get stressed out? Our brain can't make connections, and so you leave it for a while and you come back and you go, I think I have a solution. Matter of fact, there's probably somebody in here sitting right now with a solution and they don't want to give it up because, well, they might think it's wrong. They might think. Could be. So let's go an easier one. At least it's only a straight line and a diagonal. And again, did someone say, oh my God, does that mean they have an answer? Tell you what, if it pops in your head while we're doing this other problem, yes, we'll come back to it. If nothing else, before I test you on it, I'll eventually give it to you, but that ain't going to help you.
Sorry, the tests for your class, are there multiple choice or like jobs that we have to do?
Half and half. Because the AP exam is multiple choice and open-ended. So you'll get a little bit of each. All right, back to another point. This may help you out because this is going to be easier for you. Remember, to the right is a density curve for the distribution of values between 0 and 0.8. Use geometry to determine the answers to these questions. What percentage of the values lie above 0.4? So I'm going to go and draw it here. What I might do is make a copy of that triangle so it's clean. Whoop, wrong one. And move it down here. Okay, so I'll always have that. He said point what? Above what?
0.4.
Above 0.4. So that would be right here. Yeah, it is in the middle on the X. But that doesn't mean the answer is 50%, does it? Not like that other square we had. So the question is, what is this area? What is it? 0.6. Anybody else? How'd you do it, Rachel? What formula? Area of a trapezoid? 1/2 times the height, B1 plus B2. Let me fix my height there. Height. So, do I know any of those values? What's the height? 0.4. 0.4 over 2. What's my basis?
1 and 2.
Very good. She's got it.
Sorry, we don't get it.
You don't get this? You're not getting this? We're just finding the area of this trapezoid and all the numbers were given to us? We don't get it. Oh, that might be true. That's why I wrote over the H and wrote H.4. All right, back to the left. What is 0.4 divided by 2? 0.2. What is 1 plus 2? What is 3 times 0.2? 0.6. There it is. While I'm thinking about it, I might say to myself, if this trapezoid is 0.6, what's this rectangle? The complement, 0.4. That might be important someday. Okay? So, I'm going to put my answer of 0.6 over here. Whoa, why didn't it stick? I don't like it when it didn't stick. All right, try it again. All right. Next one. What? Oh, I didn't write the answer. What was the answer? Okay. What percentage of the data lies above 0.6? Well, now he's changed it. He's drawing the line here now. And I want this. And I'm only missing one value. No, the height is this. I'm missing one of the bases. So the question is, how do I figure it out? Is it just like I did the last time? Yeah, I just need the equation of that line. Is it the same thing as y equals 1/2 x? No, it's not the same line. So what I'm going to do, oh, I just want this. I don't want all that. Stop it. I only want this piece. Yeah, there you go. I'm going to copy that one. By the time I get it pasted over there, somebody's going to tell me what the answer is. Huh? What are we doing? Huh? Copy it. Okay. That good. So if I look at it, there might be no way for me to tell where this crosses the axis. It might be 0, it might not be. So that's why I'm doing this extra work. So I'll plug it in here. 0.35. Questions? You want to see the math that I was doing? Where are we at? Draw the approximate location of the median.
Wait.
Yes?
You still in C.
Oh, I thought that was C. Oh, that was the answer to B, 0.35? Oh, now I'm depressed. 'Cause I can't erase that. I have to actually tell it to delete it. There it is. All right. It says, C, what percent of the data lies between 0.2 and No, didn't we do that?
No.
Oh, we didn't do in between. All right. What percent of the data lies between 0.2 and 0.6? Well, let me go to this picture here. Let me try to just copy it. Problem is I can't see very well. And let me try to paste it here. Paste it. So I got another copy. Okay. Oh. Move that one out of the way. I'll use this one right here. So he wants to do the area between what? 0.2 and 0.6. I hope you see something jumping out.
You can just subtract
Yeah. Oh, that's a good idea. Didn't we already do work at 0.6?
Yeah.
We already know the height of that, don't we?
Yeah.
What was that height? Point what?
1.5.
1.5 was the height. And we already know this was a 2, right? So this is easy to do. This is very easy to do. Rachel, you just saved me because I was going to do it the hard way. I was going to cut it up into a rectangle and trapezoid and find these two. So I like how you think. So this area, I'll call it area 1, is how much? 0.2 times what? So that area is 0.2. This area, did we already do this area? No, because we did the other trapezoid, didn't we? Or did we do this trapezoid? We did.
You can just, because we did what lies above 0.4 and we did what lies above 0.6. So I know that like we're from 0.6 to 0.8, it was 0.35, and the total from 0.4 to 0.8 was 0.6. So if you subtract 0.35 from 0.6, it gives you 0.4 to 0.6.
0.6 from before that we talked about, minus the 0.35 that we just found out from this trapezoid, right? She said the answer is 0.25. Wonderful. So area 2 is 0.25. Yeah, she saved me a lot of work. I was not going to be that smart. That's 0.45 if we're right. So the answer is 0.45. Yes? Final answer?
Wait, can you explain that again?
It's not. Well, I can tell you it's not the answer. Because that's the answer we don't want. We don't want these places. We want the complement. We want the complement. We want in here. What do all 4 pieces add up to? What does the area of all 4 pieces add up to? 1. If the ones in black that Rachel helped us solve, that we had already talked about before, was 0.45, then the complement must be 1 minus 0.45. Point how much? No, that's 6.5. 55. There it is. All right. You guys can do the first page of the packet I gave you. All right? Just the first page. I think it's only 3 problems or 4. Oh, I didn't put it there. Paste it. It's not. Oh, there it. Oh, I copied the whole thing. Didn't want to do that. Page. There. Well, it's better than chew. No, what do they call this? Bait and switch. I'm going to sell you this nice purse, but when you get there, the purses are all sold out. Here's this ugly one, and it's half price. Okay, I'll buy it. Right? Is that what happens? Somebody, I might make you start to work, but life's
All of that.
0.35. Sure. Well, I messed that up. One more try. Oh, good. All right. Okay, guys. We want the X to be here. What is the area of the yellow? Amelie? What's the area to the right? What percentage?
I'm sure, sir. I'm just giving you a guess. Don't get mad if I get it wrong.
Okay.
Okay.
Deal.
Well, I was telling
Mallory that since it's 0 to 2, right? So 2 it's a whole, it's 100. So if it's 1, then it can be 0.5. But I was telling her that for the other problem, like 0.5, 50%.
Yeah,
But since for the other problem it was a rectangle and it was symmetrical,
right.
and this one is not, so I'm not sure. I'm just guessing that it's
So do you have a problem solving to approach this? Couple things you could do.
Is it 0.75?
I don't know. How'd you do it?
Attach
Well,
it to
I
the
found,
triangle.
like, I made a line and divided it.
Yeah, like I
and
did.
I found the area
Of?
the smaller one.
Oh, of the left-hand part,
Yes.
which is an easy thing to do because it is a what?
Square triangle.
It's a right triangle. Now, my question to you is, if you draw a 1 there, well, we already had that picture. Mallory gave us what that, or did she? No, we had something else. What's the height of this triangle?
7.5.
Oh, because base times height divided by 2 still has to, well, you're saying it still has to add up to 1. But that triangle doesn't have to add up to 1. That little one doesn't. So I don't know if that's 0.5 height. It doesn't look like 0.5 height. How could I find out where this value is right here? How could I find it? I like what she's doing. But either way, whether I decide to find the area of this trapezoid or find the area of this triangle and subtract it from 1, I still need to know how high this wall is. So you are stuck using some algebra that this is a line. Remember what I drew earlier? Call that the y-axis, call that the x-axis. That's a line. Right? There's an ordered pair over here. That ordered pair is 2 comma, how high did she say it goes? 2 comma 1? Did 2 comma 1 give me a whole area of 1? 1/2 base times, yeah, it did. So that's an ordered pair of 2 comma 1. So I have 2 comma 1. Are there any other points that I know? I don't know this point. How about here? 0. That's 0, 0. I can use algebra and find the equation of that line. The y value is the height. So I can use y is mx plus b. B is the y-intercept. What's the y-intercept of this line? Don't all yell out at once. It's staring at you. You can see it. Say it. 0. B is 0. Do I know the x value? What's the x value? No, the x value for this point right here. Oh, you wanted to use that one. Yeah, you could have used that one. I'm sorry. You wanted to use the, did someone say 2 earlier?
Yeah.
You could use either point you want. You pick one. So I'm going to go with what you did then. Because who said I'm the boss? That's my x. That's my y. All I need to do is find out what the slope is. Well, that's not going to help me. Hold on here. I need my slope. I think all I need is my slope. I'm not going to plug in those numbers. All I need is slope, and I have the equation. What's the slope between those 2 points? Rise over run. What's the rise? From here to here. From here to here. 1. It went up 1. That's the rise. What's the run? How long is that? 2. So what's the slope? The slope is 1/2. So my equation is y equals 1/2 x plus 0. There's my equation for any point that I choose to use, any point at all. So since my x is a 1, what's my y? I think you said this though. 0.5 or 1/2. Now I'm not sure how you got it, but you were right. I don't know if it was guessing or did you do some other math? I have a feeling you did some other math. That you knew it was 0.5. You didn't share all your secrets. So now if I do it her way, The area of the small triangle is 1/2 times 1 times 1/2, because that's the height. That's the height. What's 1/2 times 1 times 1/2? Say it again.
0.75.
Okay, you choose to use a decimal, that's fine. That's this area here. Is that the area I wanted? No, I wanted the yellow area. 0.75, that's exactly what she said. So we'll go back to our, so I want that little blue triangle. So if I draw what I had again, and I have this line that went through here, there's my big triangle. How do I find what the height is now? It's staring at you. It's the same equation we just used. What equation did I use? Yeah, but what was the equation? What I boxed it in. 1/2 x. Remember I said that line is the same line for any point that I choose to use? So I'm using x equals to 1/2. Can't I just plug that in to get the height? Okay. What is 1/2 times 1/2? So that height is 0.25, you said, right? Or 1/4. I'm going to call it 1/4 just because I'm a rebel. This was 1/2. This is 1/4. Wonderful. How do I find this area now? Area equals to 1/2 times the base, 1/2 times the height, 1/4. Put it all together, and what do we have? Not 1/8, 1/16. I put them into fractions because, believe it or not, without a calculator, fractions are actually the easiest thing to manipulate. If I'd kept it as 0.25 and 0.5, I might have to pick up the calculator to multiply it. Or at least do some scratch work. 0.5 times 0.25. And, it's such a pain to multiply those together, even by hand. So if I kept it as fractions, look how easy they were. Don't be afraid of fractions, all right? So I'll go back to my page. Charcoal sometimes, isn't it? Could be. I guess it's a matter of opinion. So I'm over here looking at, not this. I don't want this. I want this. I want this trapezoid. We already said the height of this was point what? The height of this side? 0.1. And this height was? 0.3. And the distance between here and here was? Between 0.2 and 0.6. How much is that? Okay. So everything is there that I need. Now tell me, what in the world is the area formula for a trapezoid? You haven't done that in 4 years, some of you. At least you know there's two bases.
1 plus base 2
Yes.
divided by height.
Yeah, no.
No, divided by half
Yes.
the height.
Yes. 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 So 1/2 times base 1 plus base 2 times the, somebody else tell me, times what? Times the height. Or some people do this. The height divided by 2 times base 1 plus base 2. Same thing. So this is a piece of cake. We have everything we need. We can put this together and make him like the $6 million man now. So what's the height of this trapezoid? Trick question. 0.4. That's the height. 0.4 over 2 parenthesis. What's base 1? I thought it was base 3 or 0.3. Does it matter? No. 0.1 plus 0.3. Becomes, what's 0.4 divided by 2? Say it again. What's 4 divided by 2? And there's one decimal place. 0.2. What's 0.1 plus 0.3? And what's 4 times 2? With 2 decimal places. Because there's 1 and 1, that's 2. Point what? Is it 0.8 or 0.08? 0.08. There's the answer to that problem. Is this a lot more Algebra 1 and geometry than you really bargained for? You kind of want your money back for today?
Yes.
Yeah, I don't blame you. Sir, we didn't have a deal on this. We said we were doing statistics, not geometry and algebra, right? So, yeah, you were scammed.
It's one.
Somebody knows. What can I do? Well, you think I'm going to draw this out. And I'm going to draw my line here. And I'm going to say that's 0.5 and that's 0.5. And I have 2 choices. Somebody, please. 5 points.
Can't you make it a rectangle?
Can I make it? Why? How? I'm not saying no. I'm saying I don't know how or why. Because I'm stuck with a triangle and a trapezoid. Each of those have to be equal to? Nope. A half. The area has to be half. All that I know for sure is that this height was how high originally? The height was 1? Yeah, because all of this was 2, right? And 2, all of this was 2. All of this was 2. And this was a 1. So I know this is a 1. But I have no idea what each of these are. It'd be so much easier if it was 1 and 1. But I doubt it. Here's why. If it was 1 and 1, then this triangle, I could plug in, y equals 1/2 x. If this was a 1, then the y would have to be 1/2. Because 1 times, so y would have to be 1/2. So that means this distance would have to be 1/2, wouldn't it? If it was a 1. If this distance was a 1. But what's that area of this triangle now? Let me just do the math. A equals 1/2. The base, you're saying, is 1. The height times a half. What does that give you? That only gives me 1/4. That only gives me 0.25. So it can't be exactly in the middle of that horizontal line. No, it's not. It doesn't work because that only gives me the area of 1/4. And I needed 0.5, not 0.25. So that tells me this line has to move to the right, doesn't it? So I'm kind of, wrong song, it's to the left. Yeah. Everything that you own is in a box to the left. Oh, okay. You're confused. So try again. Somebody. So why don't I'm going to set it up for you. I'm going to put it right here to the right. And I'm going to tell you that this area had to be 0.5.
And the other one's 0.5 too, right?
The area is 0.5, that's right. But I don't know what the x is. And I'm not sure what the height is. So, a what? A 1? No, I didn't. Okay. So, if I was a betting man, I would start talking about my area of my triangle. Base times height divided by 2. And I know for a fact the area has to be of what? Of this small triangle? A half. 1/2 has to equal to base times height. Divided by 2, that's right. Well, I can get rid of that divide by 2, can't I? Because I can multiply both sides. I can multiply both sides by 2. So 1 has to equal to base times height. 1 has to equal to base times height. Somebody else?
But base and height don't have to be the same, right?
Well, if that's true, they'd both be 1, right? And Is it possible that that height could be a 1? No, we already did the base. We already did the base as 1, remember? It didn't work. We already checked it out right here with the base of 1. It didn't work. So the base can't be 1. So now we got to be thinking of other things that could happen. I don't want to do the whole thing. I got some smart people in here. Yeah. Both of you are kind of excused from being involved because I understand you guys were ripped off. Okay, you don't like that. Bless you. I'm going to go back and look at the problem again. Put it right. I can put it here. Put it right here. Paste it. Well, it didn't go anywhere. Paste. Oh, maybe it did. I don't see it. No, I don't see it. Oh wait, is that it? No, I don't see it. I'll just draw it. It'd have been faster anyway. Was a trapezoid. Give me all the values we know. How long, what was this height? 0.2? Yeah, it was 0.6 to 0.8. How high is this going? What's his base? Up to 2. So I need the equation of this line. So if we know this went to 2, and the overall picture, how far out did it go? What was the end point here?
0.8.
Oh, 0.8. So I have this ordered pair. That ordered pair is 0.8, comma 2. I need this ordered pair. Where did this trapezoid start? What's this value right here? No. Was 0.6, wasn't it? So this is what I'm looking for. Oh, you're going, I think I need your answer though. I need to know another point that this line went. Say it again. 0.4. What about 0.4? What's the y value? 1. I was trying to hear it from somebody. I thought I was hearing it. It's 0.41. So that's a perfectly good point. So now I have 2 points to find the equation of. And so I need 2 things. The slope and the y-intercept. The slope should be really quick. Come on, the slope should be fast. We know it's still positive. So what's 2 minus 1? No. 1. Over. That's okay. That's okay. What's 0.8 minus 0.4? 0.4. So this is the same as 1 over 4/10, which if I flip the second fraction over and multiply by it, it's the same thing as 10/4, which reduces to 5/2. I think it's 5/2. Somebody can check the calculator. Is 1 divided by 0.4 2.5? Okay. So we have the slope. Now I'm missing the y-intercept. Now it'd be nice if the picture originally had it. Take a deep breath. If you know 2 points, how do I find the y-intercept?
Look at where it crosses the y-axis.
Yeah, I tried, but I can't tell. I'd only be guessing. So you're going to have to do algebra. I know you hate it. You're going to have to do this equation. Y equals mx plus b. Okay? Pick a point and plug it in. And plug in the slope. Which, by the way, we already have the slope. We already have it. We can plug it in. So pick a point. Which point are we going to pick? 1. There isn't a 1. There's a 0.4 comma 1, and there is a 0.8 comma 2. Okay, deal. So the y value here was 1. The slope is 5/2. The x value is, I'm going to use a fraction, 4/10, 2/5. How's that? Plus b. All I did is I plugged in this in the x, this in the y. And I'm almost done. There's people in this class. Whoop. I know. I can't. Is it really? What's 5/10? Oh, 5/2 times 2/5 is 10/10, which is 1. It is 0. Whoop. 0 equals b. So it is 0. So I can go back to my picture here. And I'm looking here. The y-intercept was 0. So the equation is y equals to 5/2 x. There's my equation. Will somebody please plug in 0.6 in that equation and tell me how high it goes? 5/2 times 3/5. 15/10. 3/2. 1.5. Yes? Okay. So this height is 1.5. It makes sense because this height was 1. This height is 2. It kind of makes sense. Now I'm ready to find the area of this trapezoid. All that algebra. Just wish they would have told us that we're going to have to be thinking today. Area equals to height over 2, base 1 plus base 2. I have all the information. The height somebody said was 0.2, 0.2 over 2. One of the bases is 1.5, the other base is 2, equals to 0.1 times 3.5. So the answer is 0.35. I almost made a mistake. I almost said the answer was 35. Why would that be silly? Can the area be 35? No, it has to be less than 1. Silly, yeah. So there's my answer. There it is. Are you dying to get out of here?
That was Rachel.
I know, but...
Good job, Rachel. What a whisper.
Hey, she already helped us once. All right. Whoop, too far. Well, I can put it here.